What causes seismic activity in stable polar shields? Imagine standing on a vast, icy plain in the polar regions, feeling the ground beneath your feet suddenly shake. You might think these areas are completely quiet and still, but they can still experience earthquakes. So, what causes seismic activity in these stable, ancient regions of the Earth's crust? Let's find out. Even though polar shields are known for being very old and not moving much, they are not completely free from earthquakes. Small tremors happen along old faults or weak spots in the crust. These faults are like cracks that formed millions of years ago and have remained quiet for a long time. Sometimes, the crust adjusts slowly, releasing tiny amounts of energy, which causes small earthquakes. These are not like the big quakes you see at active plate boundaries, but they show that the Earth's crust is still adjusting over time. Another big factor is the movement of glaciers and ice sheets. These massive sheets of ice weigh down the land, pressing it down over thousands of years. When the glaciers melt or retreat, the weight is lifted, and the land begins to bounce back in a process called glacial isostatic adjustment. This rebounding can create stress in the crust, sometimes enough to cause small to moderate earthquakes. For example, in Greenland and parts of Alaska, rapid melting has led to increased seismic activity because the land is adjusting to the changing weight. Large ice or rock avalanches into fjords or coastal areas can also trigger seismic waves. When huge chunks of ice or rock suddenly slide into the water, they generate waves and vibrations that can be detected far away. These landslides can sometimes cause long-lasting seismic signals and even generate small tsunamis. Such events are common in Greenland and parts of Antarctica, especially during periods of rapid ice loss. In summary, seismic activity in stable polar shields mainly comes from stress releases along old faults, the crust response to melting glaciers, and sudden landslides or avalanches. These processes happen even though the area isn't actively moving like a plate boundary. As climate change speeds up glacier melting, we might see more of these seismic signals, reminding us that even the most stable-looking places are still part of Earth's dynamic system.